Okay, sorry, we can continue this. Talking about the properties again, the symmetric, so the reflexive property, this triangle is congruent to itself, makes sense. Reflexive should look like you're looking in a mirror because of a reflection and you see yourself, might be a way to remember that. The symmetric property of congruent triangles basically says that if triangle ABC is congruent to triangle DEF, then triangle DEF will be congruent to triangle ABC, right? So if this guy is congruent to this guy, then this guy will be congruent to that guy. And again, it makes sense, just it's a property that we know we can use. And the last one is the transitive property, where we're transferring congruence, right? So if triangle ABC is congruent to, if triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle JKL, then we can transfer the congruence from ABC to JKL. Okay, and so that's transitive. I think most of you guys remember what that looks like. It looks like the same thing for triangles. Okay, all right, so some properties that we want to keep in mind. First proof, and eventually, I think I mentioned before, we're going to take the training wheels off here at some point and just and have you come up with the statements and the reasons, both all on your own. But for now, we'll still kind of help you out some. But you got a diagram here of two triangles, and we have a bunch of given information. Angle ABD is congruent to angle CDB. Angle ADB is congruent to angle CBD, and then we've got segment AD and BC congruent and AB and DC congruent. Now, for me, when I write a two-column proof, I like to lump all the givens into one giant statement at the beginning. And the reason is because it's given to us. That way I can write statements from any of that information at any time that I want. I don't have to follow any sort of certain process or any certain order. Okay, so we bring all the givens down, and if this picture weren't marked, I would start talking to you about once you say that things are congruent in your proof, you need to go mark your picture. Angle ABD is this guy here, and it's already marked congruent to angle CDB, which is this guy down here. Angle ADB is congruent to angle CBD, and then AD is congruent to BC, and AB is congruent to DC. Mark your picture because that's going to help us in trying to figure out when we're done with our proof. So that was all given to us. If I want to prove, that's the other thing we got to make sure we pay attention to, is what do we want to prove? We want to prove that these two triangles are congruent. Well, all the parts have to be congruent, right? Right now we don't have all the parts. We have a lot, but we don't have them all. And so we are missing a set of sides being congruent, and we're missing a set of angles being congruent. Now, sometimes when our triangles are touching like this, it's going to be useful to separate them, like we did in the example for the third angles theorem. This I'm going to leave together because one thing you're going to hear me say a lot is I love, love, love triangles that share sides, because segment BD is a side for the top triangle, and it's a side for this bottom triangle. And so I have to have those sides congruent in order to make the two triangles congruent. Since it's the same segment, we can use the reflexive property and just say that BD is congruent to itself by the reflexive property. Now, I love, love, love triangle sharing sides because I get a free congruent part this way. By reflexive, it's an automatic congruent part. And I call it for free because it doesn't really require any work or any other writing. We just know it's going to be congruent to itself. So we're down to angle A and angle C aren't congruent to anything or each other yet. Okay? But the reason 3 here suggests that we use the third angles theorem. Well, we've got in our two triangles, we've got two angles congruent to two angles, and so the third angles theorem says if that's the case, then the third angles are going to be congruent to each other as well. So we can go ahead and say that angle A and angle C are congruent because of this third angles theorem. At which point we'd mark our picture with some arcs. Everything's marked congruent to it, to everything, so everything in one triangle is marked congruent to everything in another triangle. There's a correspondence that we'd have to make sure that we're naming our triangles correctly, but we're done. We just need to say that our triangles are congruent. And so we have to make sure that when we name our triangles that A and C match up. And then the D in the bottom triangle would have to match with the B in the top triangle. Right? This is going to be a source of confusion later that we'll definitely make sure that we clear up. But if you look, they've named our two triangles here the way that they need to be named. So just bring it down. Triangle ABD is congruent to triangle CDB. And why is that? For right now, it's just by the definition of congruent triangles, which tells us that all the parts have to be congruent to each other. Okay? And so there's a proof for you guys to see. This is supposed to be, I don't know if this is coming through or not, but if the trial thing is down there at the bottom. This is by the definition of congruent triangles. Okay? And so there's our proof. All right, and we'll have more proofs later. This is it for the first two sections. We'll carry on next time.